Hey everyone, welcome back. We got a long road to go down. We're talking about conics. And these are conics. Conics are a parabola, an ellipse, a hyperbola. We're only studying the parabola today, but we will be getting to the other things. You should recognize vertex and standard forms of a parabola, and you should understand what the lead coefficient means. So hopefully you remember that. Let's move on. We're talking about parabolic equations and parts of a parabola. That is today's discussion. And this right here is general conic form of all conics. Now we want to limit it to parabolas only, but it does mean for an ellipse and a hyperbola. So to limit it to a parabola only, first thing we're going to do is eliminate the rotational term, the bxy term. That would rotate, now it would rotate any of them, the parabola, the ellipse, hyperbola, any of the three conics, it would rotate them all. But we are going to eliminate that, and it would give us this left. But it's still for all three. So we want to limit it to parabolas only. The way we're going to do that is either eliminate this term or that term, but not both. If you eliminated them both, then you would just have this stuff, and then we'd just be talking about linear stuff when we'd be back in the 9th grade. Nobody likes that. And so we would have these two forms where one of the variables, but not both, is squared. So you should be able to look at that now and tell me how many of the following equations are parabolas. Pause the video and see if you can come up with that. The answer is 5. This is clearly linear. Boo. Now this is conic, but it's either an ellipse or a hyperbola, and so is this. Now it could be a circle. A circle is kind of a special ellipse. Anyway, it's 5. Number 2, keep in mind it's Socrative. If I ask for the answer to number 2, that's what I mean right there. See how if you can identify the parabolas. There are 2, both variables squared, both, and both, and then linear. If both variables are squared, it's either an ellipse or a hyperbola or a circle without the rotational term, and we have eliminated that. All right, we want to be able to distinguish between vertical and horizontal parabolas. Vertical parabolas are functions, and horizontal parabolas are not functions. And so we want to use our knowledge of functions to help us with parabolas. So let's do that a little bit. Number 3, identify the function. Clearly it's that. It passes the vertical line test, and that does not. All right, number 4, see if you can identify the function. Not a function, a function. So the number 4 is B. If y is to an even power, then it's not a function. Now, mostly what we're going to see is to the 2 power, but it could be like this. Function, not a function. The answer to number 5 is A. All right, let's see what's next. So you should be able to identify this answer. Use your knowledge of functions and a lead coefficient to figure out the answer. The answer is clearly A. It's a function because y is not squared. It has a power of 1. And so it has to be one of the functions, which are these two. These two, A and C. And so it has to be A because the lead coefficient is negative. All right, number 7. Let's play this game a few times. See if you can identify the answer. It is E. That is not a parabola because both variables are squared. You got to look for that. Number 8. All right. The answer is B. It's not a function because y is squared. The lead coefficient is positive, so it will open to the right. If it were negative, it'd open to the left, kind of like up, down. Number 9, you want to isolate the linear variable y, and that would be 3x squared plus 2x plus 1. We do want to isolate. Let's see if this will work. If it doesn't, it'll be all right. Isolate the linear variable, the degree 1 variable, to be able to identify the answer, and this one is clearly C. Number 10. Oh, wow. All right, let's do some algebra with number 10. Let's distribute the 20 and square the binomial. That should make sense to you. And then let's subtract 80 on both sides, and then divide both sides by negative 20, and we get a negative lead coefficient. Now, we could have seen that from the beginning. This is actually called transformational form, and we will deal with that in the next video. So the answer to this was D, because y is squared, so it's not a function, and we have a negative lead coefficient. All right, let's move on. Let's talk about some old definitions within a parabola. The vertex, I'm not going to waste your time. That is y. Keep in mind it. Socrative. Number 11. The answer is B. Well, this isn't numbered. What's that called? Surely you know that is the axis of symmetry. That's still in play. Now let's define parabola. You may not have ever defined it. The set of all points equidistant from a fixed point, from a fixed point and a fixed line. Well, that point is not the vertex, and that line is not the axis of symmetry. And if it's not, then what are they? Well, that's what we're investigating. Yay. The set of all points, that's just restating it. That's the definition. Let's move on. The set of all points refers to the actual parabola, all those red dots, the set of all points. Equidistant. We're going to come back to that idea in another computer program in just a minute. The fixed point is called a focus. You got to focus on the focus. And there's some essential properties of the focus. It is inside the parabola. It does not touch the parabola. And it is on the axis of symmetry. I'll just draw that in. It is on the axis of symmetry. All right, and then the fixed line within the definition is, again, not the axis of symmetry, but it's something called the directrix. Directrix. Man. Essential properties of a directrix. It is outside the parabola. It does not touch the parabola ever. It is perpendicular to the axis of symmetry. So if I drew that in, it's perpendicular, right angle. Yay for the right angle. All right, a vertical parabola must have a horizontal, see if I can get this to work, directrix. And a horizontal parabola must have a vertical directrix, something like that. All right, equidistant. We need to investigate this. I have this set up in a computer model of a parabola. A is the focus. B is just any old random point on the parabola, and C is on the directrix. So now if I were to move point B around, and that distance, let's point this out, AB is 3.78 and BC is 3.78. And if I move point B around, it's not that those distances are going to stay 3.78, but they will stay exactly the same. I mean, if you think about that, that's pretty darn fantastic. And think about the definition of a parabola. It's a set of all points, equidistant from a fixed point and a fixed line. I mean, we're saying that. And then it gets really, really interesting when we overlay point B, or point B becomes the vertex. All right, and then that distance from A to B is called the focal length. All right, that's something new. Let's get back to the presentation. I'm missing it. Come on, presentation. Come back. All right. So there's, all right, number 12. Let's answer that. Well, clearly the answer is A. You know, if X is 10, X equals 10, then Y has to be equal to 10. But you have to be careful. And number 13, don't be tricked, because this line segment right here, I don't know if I can move it or not, has to go to the focus, not the vertex. You'd have to put E for this. That's a little tricky. Don't let me trick you with that. All right, and then again, these distances have to be the same. This right here is the focal length. And hey, this is math class. We like to give things names, and we usually call them letters. The focal length is called P, the focal length P. And it occurs twice. By definition, it's this length, and then also it's that length, if you combine it with the definition of a parabola. All right, that is P. Let's move on. All right, so what's that length in terms of P? Oh, I don't know. Maybe it's 2P. We can come up with that. And then there's something called the focal width. All right, I want to investigate the focal width, that length right there in the next slide. All right, we just saw that this piece right here is 2P, so that piece would be 2P. And also, by definition of a parabola, that would be 2P. And I think we can handle that this piece right here would be 2P. So the focal width is equal to 4P. Wow, 4P. All right, some essential properties of the focal width. Not only is it equal to 4P, but there's some things about it. It contains the focus, or the focus is the midpoint of it. It is parallel to the directrix. That's this down here. And it is perpendicular to the axis of symmetry. That's that line right there. Love those right angles in there. All right, let's move on. All right, some new definition problems. Let's look at that. Which point is the focus? Well, clearly that's point X, which is choice C. I'll be asking all this stuff. The focal length P. Well, it occurs twice, but by definition, it's right there. It's X, Y, D. Number 16, which is the focal length 4P. We just said that. That is this distance from T to Z right here. Number 17, let's move on. The directrix. The directrix is a line. It's not a line segment. So all of these would be out. It's either F or G. And then clearly it's this down here. So it's UW, choice G. And number 18, the axis of symmetry. I guess that's an old thing, but it is a line. And so we'd have to name it UX here, U to X. It could be UY, any two letters on the line with a line symbol. Moving on. All right, you might want to pause the video and see if you can come up with that. It's pretty simple. If that length right there is 5, that's what that is saying, then what is this length, AD? Well, we just learned that it is 5 as well. So it will be numeric over time. And if, all right, DB, let's see, AB is 5. DB, that would be that length, is 10. And then a question could be, what's that length? And it would be 4 times 5, which is 20. But I don't know if I'm asking that or not. All right, I think we have 3 more problems. This has been so much fun. I don't want it to end, but see if you can come up with that. Let's draw it. Gosh, I don't know. All right, the directrix is x equal 4, 1, 2, 3, 4, and that gives us a vertical line. That means we have to have a horizontal parabola, and the focus is negative 5, 6, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. And the vertex would be halfway between there, so it'd be somewhere in there, and it would have to open up that way. And so if we go back to this problem, it was choice D. These are fun, and then we'll actually come up with the coordinates of the vertex and the focus and all that later. All right, number 22, pause the video and see if you can come up with that. I'm sure you can. Let's see, the vertex is negative 2, 3, 1, 2, 1, 2, 3. The focus is, I'm going to put a V for vertex, negative 2, negative 1, and that's the focus. And so it would have to be like that. The focus is inside the parabola. And so it's opening down. I'm so sad because we only have one more problem. I want to do a ton more. All right, number 23, pause the video and see if you can get that right. I have faith in you. Y equals negative 1, that's the directrix. That means our parabola has to open up or down. The vertex is 3, 3, 1, 2, 3, and that's the vertex. Have to pay attention, it's not the focus. And so it would be something like that. The focus would be up here, and we could find that, and we will find that in the future. Guys, I'm so sad that we're done, but I am happy that I got to see you today. All right, guys, later.